Hello, welcome. Typesetting matrices of different size in different style using LATEX is the main topic of this video. See this example. In the various types of matrix typing can be explained using this example. Here we have a problem. You have to produce the output, and this problem is to produce the output which is appearing in this box. So the system of equations x plus y minus z equal to 1, x minus y plus z equal to 1, x plus y plus z equal to 1 can be written in the matrix form as 1 1 minus 1 1 minus 1 1 1 1 1 into the matrix the column matrix x y z equals the column matrix 1 1 1. Here the matrix 1 1 minus 1 1 minus 1 1 1 1 1 is invertible. So this is the content of the expected output. Here you can see a system of equations is given as the first part of the content. That can be done using equation by using some mathematical environment, some suitable mathematical environment, and the second part contains three matrices. First matrix is a 3 by 3 matrix. There are 3 rows and 3 columns. And the second matrix is a 3 by 1 matrix. It's a column matrix, 3 rows and 1 column. And the last matrix is also a 3 by 1 matrix. And finally, the last part of the output is the square matrix, the same square matrix 1 1 minus 1 1 minus 1 1 and 1 1 1. You can see the source code that can generate this output is given just below that. Below the problem, but you have to analyze this source code line by line or term by term in order to understand how the output can be generated. Coming to that source code, this is the first line is an ordinary running matter in the system of equations. So only ordinary typing is required. After that, you come to, so see we are analyzing the output. So you can generate the source code only analyzing the output step by step or line by line and word by word. You have to analyze it. You have to understand the output. First you have to study the output. So this is the output. This technique is applicable not only in this case, in all cases of LATEX typesetting, and this is the method. So you have to analyze the output, or you have to imagine about the expected output. You have to visualize in your mind the expected output, and based on that imagination, you have to write the source code step by step or word by word. So first you have the step, the first line of the output. It's an ordinary matter. So that you can type as usual. okay, without any special environment, it can be typewritten. After that, you come to this point, you come to a mathematical expression. That mathematical expression, now you can see that it contains three equations. Together, these three equations have to be included in one mathematical environment, but these equations are aligned in a uniform manner. These equations are aligned, and not only that, there is no numbering given to that system of equations. So that's also important. No numbering or no labeling is given to the system. And so you can think about the different ways of generating such an output using mathematical environment. You can also note that there is no ordinary matter. All are mathematical terms or expressions. You can see here x, y, z. All these are mathematical letters or mathematical terms. So there is no need to include the any text matter, any ordinary text matter inside the mathematical expression. So these are the points that you can notice about the that current mathematical expression that we are going to write its code. Okay, so now we can select a suitable mathematical environment. Now to typeset the mathematical typeset this mathematical expression, you can choose the align environment. Okay, so begin align and /end align can align commands can be used to completely typeset the three set of these three equations, the set of three equations. And that part you can see in the source code /begin align star is given because we don't like to give any label to this system of equation. So after that, x plus y minus z, you should by using usual typing x plus y minus z, but and is used in order to divide it into two fields. So you have the first column field here. This is the first column field, and then after equal symbol, we have the field, the second column. So in the first column, x plus y minus z, and just below that x minus y plus z, and below that x plus y plus z are the expressions that are expected to be typed. Okay, then the remaining rest will be typed in the second column. So for that, in order to get such an output, we use the and symbol. In each line we have to use and. So x plus y, after typing this and is typed. After that equal to 1. Then remaining matter should go to the next line. So we use double backslash. A double backslash. Okay. After that, you can type x minus y plus z. That is in the first column. So we can use and then equal to 1. Again, two backslashes can be used. After that, x plus y plus z and equal to 1. So by that, first mathematical expression or first mathematical environment is now complete. Therefore, you can close it by putting /end align star. So you may note that while typing with LATEX, you have to finish each completed portion of or each meaningful portion. Meaningful portion means a portion of the source code that can give you an output. A small such portions are there, such sections are there in each program. So such that kind of small sections must be identified and you have to complete the typesetting of such small portions. Then you have to take the output. You have to visualize it. You have to see the output. That will let you know that whether the program is working properly, whether you have made any mistake in it. So instead of that, if you are trying to typeset the entire thing or complete thing right from the first step up to the last step, I mean slash end document, then and after that, if you are trying to take the output, there you, by mistake the typesetter may make a large number of mistakes or erase a large number of arrays may be there in that entire typeset matter. So what happens is when you take the output, when you try to take the output, it will show a large number of arrays. So for a beginner, many mistakes cannot be detected simultaneously while you are sitting in a practical examination room. So that will be very negative. That will create very negative impact on that on your performance. That means that situation will increase your tension, and finally you will not be able to identify all arrays. So that will affect your performance. In such a situation, you will not get good marks. So in order to avoid that, you have to identify each complete sections in the source code, and step by step you should take the output, and that way you can proceed up to the end of the programming. From the starting from the beginning, you can apply this method, and you can proceed up to the end of the programming. So this is very important. It's an important tip to perform well in a better way and score maximum in the examination type. So keep it in mind. Therefore, coming back to the source code, you can see this is a completed portion or a complete a meaningful section of the source code that is from the line /begin align up to /end align. So you can copy that or you can typeset it and view the output. I am going to do that now. First of all, you can type this in the first line in the program. Okay. So this is a new material or a new a new part of the material. So I am giving a separation. After that, I type the first line. There no need to run it now, because there is no chance of making an error by the system at this stage, because it contains only ordinary matter. Therefore, you can look at the remaining part, and then you can one by one you can type up to this meaningful or completed part of the source code. So that will generate this mathematical expression. The system of equations will be completely generated by this system of this set of equations. Okay, so that is typed there. That is typed. Okay, then now you can take the output now. The output has been generated, and you can see here just below that line, the start line, we have the system of equations and the actual mathematical environment you can see as appearing in the in the manual. Now you can think about typing the next line, and this line it contains only ordinary matters. Okay, so you can just copy and paste it there in the program. You can do that. Then we have after that we have the next mathematical environment, the second mathematical environment we have, in which there are three matrices, or the matrix equation is given there that we have to complete. So knowing how to type the matrix is very important here. How can we type the matrix? For typing matrix, we have different methods, or different commands. Actually, I mean different commands. Depending upon the type of the matrix, we can vary that command to obtain the output, a varied output. Now here we have the matrix. We have matrices in different style. Some matrices have the bracket, the enclosing bracket. It is like one which is appearing here. That is ordinary bracket. You can see some matrices, but in the case of some matrices, you have square brackets to enclose the rows and columns in the matrix, and there are some other matrices. In the case of some other matrices, the rows and columns are enclosed by vertical line type parentheses, or vertical lines are used to enclose the rows and columns. So how can we, the question is, how can we produce this kind of this varying type of matrices? So first, as an example, first case you can see here we have that matrix. So when you come to when you enter this mathematical environment, you can see that this is after the term after the terms are after these words terms as you have the mathematical environment. So you are entering the mathematical environment. So immediately you have to give you have to tell the system, the LATEX system, that I am going to generate a mathematical environment. So a corresponding command must be given. And as you enter that mathematical environment, you will face the first matrix. After that, into the second matrix is there. After typing that, you have the equal symbol. Then once again, one more matrix is there, the third matrix. After typing the third matrix, you have to exit that mathematical environment. This is the style of the this is the structure, or this is the order of typing that part of the source code. So you have to keep an order when you typeset some LATEX source code lines. So that order must be there. If you alter that order, your output you are not going to get in a proper way, and there will be errors in the output. Okay. Now you can see that mathematical environment is started with the command /begin equation star. So since we don't want any label to put here or to use along with this mathematical expression, so we use equation star. /begin equation star. Then inside that so when you see this this command, you can understand that the typesetter has started a mathematical environment. So /begin equation star. After that, to type the matrix, a separate command is used. So for typing the matrix, this is the command, one of the commands that can help you to type the matrix. /begin p matrix. /begin p matrix. So as you enter the /begin p matrix, you have the entries in the matrix: 1 1 -1 1 -1 1, etc. These are the entries in the matrix. So starting the matrix, you can use /begin p matrix. Then you come to the first line. In the first line, first element is 1, second element is 1. So and also you can see that these elements are entered here in columns, in 3 columns. So you have the elements in 3 columns. We have elements in 3 columns and in 3 rows. So actually the rows can be specified here by using new line command. After finishing each row, you can give the new line command. The new line command is double backslash. Okay, but for specifying different columns, you have to put and a character. As many columns are there, that as many as columns are there, many and operation or and symbol must be given. Okay, so you can see here in the source code. In the source code, you can see 2 ands are there, are given. See, first you have to type the number first element 1, then and is used. So that indicates that the first entry in the first column is over. Next entry comes in the next column, in the second column. In next entry in the second column is also 1, and that after putting 1, you have to specify remaining element must go to the third column. So and -1, and after typing -1, you have to tell the system that next entries must go to the next line or next row. So for that you can use double slashes, and then you can continue as in the previous case. You can continue entering the number. So 1, then and -1 and 1. After that new row command must be given two backslash and then 2 backslashes. After that the elements in the last row can be ended 1 and 1 and 1. So if you miss if any at least one of the and is missing, suppose by chance if you forget to give this and, then there will be a big error. That will lead to a big error. You will not get you will get only error message, you will not get any output. So the number of ands used here is very important, and that number must be 1 less than the total number of columns available in that matrix. See, here there are 3 columns, so we have to use 2 and symbols in each row. We have to use 2 and symbols to separate the elements in the columns. After finishing that entry in the matrix, you have to end the matrix environment. See, here we have opened a matrix environment by using pmatrix command /begin pmatrix. Then we end up we have to close that environment /end pmatrix. And then we are not going to close the equation environment that we have opened here. The equation environment we have opened here will still be kept open because we want to enter the other 2 things. It is not complete actually. So we have to we are now going to enter the next matrix and then equal to symbol and then the last matrix. So we finish that first matrix entry in the first matrix. Then again we encounter or we face the second matrix, and that matrix can then be since that matrix is in the since that matrix have the same style. So we can use the same command /begin pmatrix. We use /begin pmatrix. After that you can see how many rows are there and how many columns are there. There is only 1 column, so these entries can be then ended. As you enter the second matrix, you can see the x is the first element, so you type x the first element, but the next element goes to the second row, so you have to put 2 backslashes, and then y is ended as y is the entry in the second row. Then again you put 2 backslashes to specify that next entry must be in the third row, and that is z. So after typing z, you come to the end of that matrix, so you have to close that opened matrix environment /end pmatrix. Then you have the equal symbol that you can put here after finishing the second matrix, and this is the point where we finish that the second matrix there. Then you have to enter, you have to type the equal symbol. After completing that typing of equal symbol, after typing equal, you come to the third matrix in that in the mathematical environment. The third matrix is there. Then then we begin another matrix environment / begin p matrix. In that p matrix, in that matrix we have the one. We have 1 as the first element. So 1 is typed, and then new line command 1 by 2 backslashes is given. Again 1 in the second row. So 1 again typed, and by 2 backslashes. 1 in the last row. So we finish it. We finish that. We have to finish that matrix. So we type /end p matrix. Then we have finished that mathematical environment completely. We have finished that mathematical environment. So after completing that end p matrix, you have to close the open mathematical environment. That mathematical environment is still it remains open now, but you have to close it. So we use the command /end equation star. We have to close that using the command /end equation star. After finishing the typing up to this point, then you come to the ordinary matter here, comma, the matrix. So that is typed as its continuation as usual here, comma, the matrix, and then you have a new matrix. That matrix can be but that matrix is completely equal to it is exactly the same as the matrix used already typed there. So you can apply that copy and paste method, but you have to identify that matrix part in the source code. See that this matrix is actually typed here from /begin p matrix up to /end p matrix. So you can start copying from this point in the source code up to this point, okay, up to the end of the p matrix. So you can copy, but before that you should note one thing, that you have to open a mathematical environment here. You have to open a mathematical environment. For that you can just type you can just type the mathematical you can type what, then you can type begin equation star and end equation, okay, but then end matrix, then end equation, okay, and hence the matrix here the matrix. After that you can see /begin p matrix environment is used. Okay, without that you can without that mathematical environment itself, this command itself is given for creating that p matrix, for generating the matrix. That command is used. That means even without that separate command for generating a mathematical environment, it can work as a mathematical environment. The p matrix command can work as mathematical environment. So we can use that command to open. That you can see here that single dollar is used. That's a mistake. I haven't noticed that. You can see here the single dollar is used, and to close here the command single dollar command is used to open the mathematical environment. So using the single dollar command, this mathematical environment is opened out, and then what we do, we type that matrix inside that inside the single dollar, and then you can close it with using the dollar symbol. You can close that using the dollar symbol. So it's very important here also. This every matrix p matrix every matrix environment must be inside the inside a suitable mathematical environment. But you can see here in the output this the mathematical environment this matrix mathematical environment comes as a part of the paragraph, you know, as a paragraph, or it comes as a part of another running line. So you don't have to use that that centralizing type of mathematical environment such as begin equation, end equation. You can you have to use that single dollar mathematical environment. Then only you will get it as a part of the line. That mathematical expression will come as the part of the line. That's why. So you know, you can thus you can use the single dollar to begin that mathematical environment, and you can then copy the matrix from the previous step, and after copying and pasting it you can finish that mathematical environment using the dollar symbol. Finally you can type is invertible. So I am going to step by step I am going to do the things, and will show you the output. Okay, first this matrix, this begin okay, yeah, this begin align, that I have finished, that portion I have finished. I can show. Okay, that is now what remains to type here is the then it can be written. Okay, that you have to type. Okay, that's also there. So we have to type the rest slash begin equation. See, slash begin equation, when we use slash begin equation, you have to complete it with the slash end equation. Okay, another slash begin equation command should be completed using slash end equation. E and D, then only it becomes a completed section. Okay, you can whatever thing you want to enter can be whatever matter you want to typeset inside the commands. You can do that in a meaningful fashion only, you know. So you have to select this matrix, the first matrix part from slash begin p matrix up to this slash end p matrix. That matrix will be now entered inside that. So inside that you can enter that. Okay, I am going to take the output of the portion that I have typed. Okay, some error, it is showing some error, missing dollar instead. What is the error? And that we have to check. Some error, it shows some error message, it gives some error message. Slash end p matrix, p matrix p matrix, and slash end equation star, slash end equation star, slash begin equation star. Slash end slash end equation 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 star slash end p matrix p matrix. Let's check it again. Yeah, and the problem shown by that system. Some one error message was shown by the system. It was due to that space extra line provided between the commands. I cancelled it to obtain the matrix the output, and this is the output. You can see here the system of equations on the first mathematical environment, and then the ordinary line. After that, in the mathematical environment, we have the matrix, the first matrix. And we can after that, after obtaining such an output, you can confidently you can proceed to type the rest of the thing. So that is the method this is the method that can be followed to avoid errors in while typesetting. So you can you have to create enough space for entering the rest of the thing. You can see end equation has that command has been now moved down by leaving much enough space to enter the rest of the thing in the complete part of that, or the meaningful part of the source code. Now I am going to enter the next matrix, the second column matrix, and that is this is the matter. That matter is copied, and I am going to enter it just after the first matrix. After closing that first matrix, I will enter it. Now it is now okay. It is entered. Now what I am going to do is to take the output. I want to view output at each step. After finishing each step, you can see the same error message is displayed. Once again, I have to say that I have left an unnecessary space between this command, so that space must be cancelled in order to get an output. So that is important. You can note that also, that important thing. Okay, now I have obtained the second matrix in that mathematical environment, the product of the matrix. Next, what should appear? What should come next? The equal symbol and the last matrix. So you can finish all those in one step. If you want, you can finish it in one step. You can put the equal sign, and then the last matrix you can copy. You can enter that matrix in the source code. Okay. For that, I will make that space for entering that. Okay. Then I copy it. Okay. Then if you feel that it is an extra space provided, now you have to cancel this extra space for getting that, for avoiding the error. I am going to view the output. You see that matrix, that mathematical environment is now complete. We have obtained that mathematical environment completed. Finally, coming to the last part of the we come to the last part of the programming. Okay, here we have the matrix. Here the matrix that you can select and type it. You can select and copy and type it. That you have to type outside that mathematical environment. You will do that. You have to type it. After this step, you have to use that single dollar to open another mathematical environment. This single dollar is given, and okay. So after putting $2, you can leave enough space between them. You generate the space, and in that space I am going to copy that portion from a portion of the matrix only, not that dollar. That I want to show that you are not copying that dollar. It should not repeat. Otherwise, you can copy entire thing, including that dollar. And you can copy it in the place for that. Okay, entire thing I am copying here. Sorry, and that is not properly copied. I have copied, and then I will enter it here. Okay, that end document has come just above that. So sometimes it happens, you have to copy it down. Okay, next it's okay it's properly there, it's appearing there properly. Okay, next next you can view the output. Let's check whether it is complete. Now it's invertible. That's ordinary matter. That matter is also typed there. After that, after finishing the matrix, you can type it here. Okay, it's invertible. It's invertible. Actually, how does it come? It appears in the next line. So since it appears in the next sorry, here it is not it appears in the same line, not in the next line. It appears in the same line. So to get such an output, you have to see first. Let's take the output of the let's take the output first, then we will decide what kind of changes need be made there in the last portion of the source code that we have typeset. You can see here in the last line here the matrix is appearing, but and the matrix is also appearing, but you can see is invertible is going to the next line. It's typed in the, or it is displayed in the next line. To cancel that, and if you want we want to bring it back to the previous line, so that can be done using see here, coming to the source code. You can see a space here. Some space is left there after that, after completing that matrix. So you have to finish you have to cancel that space. Now it's okay. Since that that the two words is invertible comes immediately after that, after the completion of after completing that matrix, you can see the output will appear in the line. The last line output will appear in the previous line. That you can check. Okay, yeah, this is the output that we get. So that is the end of the explanation of how to type matrix. We will come with prepare another video that will explain different or various types of matrices or matrices in different style. That can be explained using another video. But now this is we come to the end of the problem of typesetting the output which I showed in the beginning. Yeah, this is the output. We have obtained that output in a nice fashion. We have obtained that output. Okay, thank you.